Good day, everyone. Today's video learning, we are going to talk about discrete probability distribution of the given random variable. Last time, we discussed and we defined random variable, and we also classify discrete and continuous random variable. And today's video learning, we are going to talk about discrete probability distribution. And what are our objectives for this video learning? Number one, define and illustrate a probability distribution for a discrete random variable and its properties. Number two, construct the probability mass function of a discrete random variable and its corresponding histogram. And last one, compute the probabilities corresponding to a given random variable. And to start with our discussion, let us first explore this experiment. Suppose three coins are flipped or tossed and we are interested to determine the number of heads that will come out. Meaning to say, our event here is to determine the number of heads that will occur when we flip three coins. And using the previous discussion about this experiment and leading to an event, I do have here the three coins. And from the given three coins, the possibility or the possible outcomes for first flipping will be head or tail. Hence, I have to show you the first flip or the first toss. We have head or tail. Okay. Then, second, we do have head or tail, meaning we can have the first flip, it can be head, and for the second flip, it can be head also, or it can also be tail. Okay. Then we also have head and tail for the second flipping under the first flip of getting a tail. And for the third, we have head or tail. Same thing, we have head or tail. Then we also have head or tail. And then the last one is head and tail. Now, from the given diagram that we have, we can now determine what will be our outcome. Now, looking on the given diagram or illustration, we have head, head, and another head. Okay? We also have head. Okay? We also have head, tail. Okay? And then we have head. Or we can also have head, head, and tail. Okay? Head, tail, head. Or we can have head, tail, and then tail. Okay? Then, for the first flip, we have tail. We have tail, head, and head. For the second one, we have tail, head, tail. For the third one, we have tail, tail, head. And last one, tail, tail, tail. Therefore, we do have 8 outcomes. And from the given outcomes, we are looking or we are interested on the number of heads that will occur based on the possible outcomes that we have. And by there, we can have the random variable. Okay? Since we already have the outcomes, head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, tail, tail, tail. Therefore, X now will become the number of heads. And we do have 3, we have 2, we have 2, 1, 2, 1, 1, and 0. And from this number of heads, therefore, this will become our random variables. We have 0, 1, 2, and 3. And by knowing the number of heads, we can also determine the number of the given random variable. For example, if x is equal to 0, how many 0 do we have? We have 1. Okay, if the number of heads is equal to 1, how many outcomes contains head equal to 1? We have 1, which is head, tail, 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 head, tail, and then tail, tail, head. And we have 3. Now, for the number of heads, which is 2, we have outcomes head, head, tail, head, tail, head, and we have tail, head, head, which is also 3. And for 3 heads, we have head, 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 which is equal to 1. Therefore, the number of outcomes is 8. And knowing the frequency of the given random variable, for example, 0, no head at all, we have 1. 3 heads, we have 1. 1 head, we have 3. And 2 heads, we have 3. And from this concept, we can now define and illustrate what is discrete probability distribution. Okay, now what is discrete probability distribution? It is a table or a formula listing possible values that a discrete random variable can take on along with the associated probabilities, meaning to say there should be possible values coming from a discrete random variable, and it can be written in a form of table or in a form of formula wherein there is what we call corresponding probability along with the given discrete random variable. And we do have two ways, as mentioned. It can be written in the form of tabular form, or it can be written in the form of equation form. And to better understand the concept about discrete probability distribution, let me show you the example. In the tabular form, since the number of heads or the random variables are 0, 1, 2, and 3, and knowing how many 0 do we have 1, and our total outcomes is 8. Therefore, the probability that no head will occur is equal to 1/8. Okay, on the other hand, the number of heads is equal to 1. Okay, we have tail, tail, head, head, tail, tail, and we have tail, head, tail. Therefore, we do have three outcomes that contain one head. And since we do have a total of outcomes equal to 8, therefore, the probability that our x is equal to 1 is 3/8. Okay? And for the given x is equal to 2, meaning to say there are 2 heads, the probability is equal to 3/8. That are, we have head, head, tail, tail, head, 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 tail, head, all over the number of possible or total outcomes, which is 8. Hence, our probability for 2 heads will be 3/8. And last one, we do have 3 heads, and the probability is equal to 1/8. Now, this is in the form of tabular form. Okay? We have the number of heads or the random variable 0, 1, 2, and 3, and its corresponding probability. On the other hand, we do have equation or in function form, wherein we can write this one into f of x is equal to 1/8 if x is equal to 0, 3/8 if x is equal to 1, 3/8 is if x is equal to 2, and 1/8 if x is equal to 3. And this is how we are going to illustrate our discrete probability distribution using equation or function form. Okay? Now, I hope you understand the concept. Now, let's go with the properties. Okay. Now, what are the properties of the given discrete probability distribution? Going back with our illustration based on the number of heads. Okay. Now, if you are going to determine the probabilities or the probability of a certain random variable, now the maximum probability will be 100%, and the least one is 0. Okay, looking on the given example, we do have 1/8, we have 3/8, another 3/8, and 1/8. Meaning to say, the probability of the given a particular random variable as a value will be from 0 to positive 1. And if you are going to get the sum of the probability, we have 1/8, 3/8 plus 3/8 plus 1/8. Therefore, this will become 8/8, which leads to equal to 1. Therefore, the sum of the probabilities of the given discrete probability distribution is equal to 1, which leads to our properties. Number one, the values of a probability distribution are probabilities on the interval from 0 to 1. By notation, we do have P, or the probability of X is greater than or equal to 0 but less than or equal to positive 1. On the other hand, the sum of all the values of a probability distribution must be equal to 1. It should not be greater than 1 or less than 1. It is always equal to positive 1. Okay, I hope you able to understand or get the concept about the properties of discrete probability distribution. Okay? And since we do have now the concept of the discrete probability distribution as to how are we going to illustrate and what are the properties of the given discrete probability distribution, now let's look for the graphical presentation of the discrete probability distribution. Now, when we talk about the graphical presentation of the given discrete probability distribution, we can use the histogram. And what is a histogram? Histogram is a bar graph, okay? And to construct a histogram for a probability distribution, we are going to follow the steps. Number one, plot the values of the random variable along the horizontal axis. Okay, you are going to plot or utilize the values of the random variable and write that one in the horizontal axis. While the probabilities of each random variable should be written in the vertical axis. And to illustrate further the histogram of the previous experiment that we had, then this will become the graphical illustration. First, now this is our discrete probability distribution in a form of tabular. And then this now is our histogram. Okay? Now the probabilities is written in the vertical axis. We have 5/8, 4/8, 3/8, 2/8, 1/8. Okay? And then we do have the random variable expressed or written in the horizontal axis, which are 0, 1, 2, and 3. And this is now the illustration or the graphical presentation of our discrete probability distribution under the given three heads when we flip three coins. Okay? Now, I hope you learn about how we construct histogram or the graphical presentation of our discrete probability distribution. Okay? And to further learn with our discussion about discrete probability distribution, now let me give you an example. Okay, now here we are asked to construct a probability distribution or the probability mass function of a discrete random variable x, where x is the number of red balls when two balls in succession without replacement from an urn containing four red balls and three blue balls are drawn. Actually, it was already presented in the first a video about random variable, and we are going to use that concept. Okay, now there are only two balls to be drawn from the given four red and three blue balls. We are asked to construct a probability distribution and to make a histogram for this probability distribution. Okay, to answer the problem that we have, let's go with our diagram. Since we only have two colors, the red and the blue, therefore there is a possibility that on the first draw, you can get red or you can get blue. On the second draw, therefore, there is also a possibility that you can select or you can get red or blue. Same thing, you can have red or blue. Therefore, from this illustration, we can now have our outcome or possible outcomes. It can be red, 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 blue, blue, red, and blue, blue. And since our focus is to determine the number of red that will appear or will be drawn from the given four red and three blue. Therefore, we can now have the number of the red balls. We have 2, 1, 1, and 0, which leads to the given answer to our problem. First, we are asked to construct the discrete probability distribution using the tabular form. We have, if our x is the number of red balls, then we can have 0, 1, and 2. And its corresponding probabilities are 1/4, 1/2, and 1/4. Okay? Now remember, there are two outcomes where the number of red balls is equal to 1. We have red, blue, and blue, red. Therefore, the probability is 2/4 because the total outcomes is equal to 4. But since 2/4 can be reduced or is simplified, then our answer will become 1/2. Okay? Or if you do not want to have tabular form, you can have the equation or the function form, wherein f of x is equal to, we have if 1/4, then we have x is equal to 0, meaning to say the probability of x when x is equal to 0 is equal to 1/4. The probability if x is equal to 1 is 1/2. And the probability if x is equal to 2 is 1/4. Okay. Now, aside from the construction of the discrete probability distribution, we are also asked to illustrate the histogram. And as to the histogram of this experiment or a particular event that we have, then we do have the given histogram for this problem. Okay. Now, as you can see, okay, if our x is equal to 0, then the given probability is 1/4. If our x is equal to 1, then the probability is 1/2. And if x is equal to 2, the probability is 1/4. Okay? Now, I hope you're able to learn with our example number 1. Okay, and to further learn with our discussion, let's proceed with another example. Example number 2. We have construct a probability distribution of a discrete random variable x such that x is the sum of the points on the upturned faces of the dice when a pair of dice is rolled. Make a histogram for this probability distribution. Okay. Now, in this case, it is being asked that we are being asked to construct the probability distribution of the given discrete random variable x, wherein the x is the sum of the pair of dice. Okay? When the pair of dice is maybe rolled down, okay? Okay, now in this case, now let me show you the possible outcomes. Since cube, the die is, or the dice have 6 faces, then the possible outcomes for the first die will be 1, 2, 3, 4, 5, 6. If we do have pair of dice, then we can have first 6 and the other one is 6, and then we can now pair it, therefore leading to the given set of pairing relative to the faces of the dice. Okay? For example, on the first dice, we have 1. And then for the second, we also have 1. Therefore, we do have 1, 1. Okay? Or we can have 1, 2. Or we can have 1, 3, 1, 4, 1, 5, 1, 6. Since you do have a pair of dice. Okay? Therefore, the possible outcomes are 36 outcomes. We have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, up to 6, 6. Okay. Now, in this case, we are interested on the sum of the faces. Therefore, if we are going to get the sum of 1 and 1, this will become 2. 1 and 2, we have 3. 2 and 1, another 3. Okay? And for easy understanding, let's go with this one. This is 1 and 1, we have 2. We have 1, 2, and 2, 1, it's 3. Next, we have 1, 3, 2, 2, 3, 1, we have 4. 1, 4, 2, 3, 3, 2, 4, 1, we have 5. Meaning to say the sum of the upturned faces of a pair of dice. Next, we have 1, 5, 2, 4, 3, 3, 4, 2, 5, 1. We have sum of 6. Next, 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. We have 7. Next, 2, 6, 3, 5, 4, 4, 5, 3, 6, 2. We have 8. Next, 3, 6, 4, 5, 5, 4, 6, 3. We have 9. And then we also have 4, 6, 5, 5, 6, 4. We have 10. And 5, 6, 6, 5. We have 11. And 6, 6. We have 1. Therefore, we are interested on the sum of the upturned faces of the pair of dice, which leads to 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay. Now, this will become our random variables. We have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. The sum of the upturned faces of a pair of dice. And before we construct the probability distribution of this particular experiment or event wherein we look into the sum of the upturned faces, now we have to count first how many outcomes contain a sum equal to 2. we have 1. Okay, that is 1, 1. For the sum of 3, we have 2, 1, 2, 2, 1. For the sum of 4, we have 3, we have 1, 3, 2, 2, 3, 1. And then for 5, we have 4. For sum of 6, we have 1, 2, 3, 4, 5. For the sum of 7, we have 1, 2, 3, 4, 5, 6. For the sum of 8, 1, 2, 3, 4, 5. Sum of 9, 1, 2, 3, 4. Sum of 10, 1, 2, 3. Sum of 11, 1, 2. Sum of 12, 1. Okay. And from the given number or frequencies. Okay, for the frequencies, if we are going to add this one, this will become our denominator of the probability corresponding to x is equal to 2 up to x is equal to 12. And you can also simplify if the numerator and denominator is divisible by a certain factor. Okay? And from this, we do have the probability of our x is equal to 2. We have 1 over 36. Since the sum or the total outcomes is equal to 36. We have for 3, we have 2 over 36 or simply 1 over 18. For 4, we have 3 over 36 or simply 1 over 12. Next, we have for 5, we have 4 over 36, but it is divisible by 4, therefore we have 1, 9. For sum of 6, we have 5, 5 over 36. For 7, we have 6 over 36, which is 1 over 6. And then we have 5 over 36, 1 over 9, 1 over 12, 1 over 18, 1 over 36. Now, these are the probabilities of each random variable. Okay? And to illustrate the histogram that we have, okay, now we have this illustration to represent the histogram of the given event. Okay, now if x is 2, we have 1 over 36. If x is equal to 3, we have 2 over 36 or 1 over 18. For 4, x is equal to 4, we have 3 over 36 or 1 over 12, and so on. Okay, now as you can see, this is now the histogram of the given discrete probability distribution. And if you are observing, okay, they are symmetrical of each other. For example, when x is equal to 2, the probability is the same with x is equal to 12. The probability of random variable x is equal to 3, that is 2 over 36. The probability of x is equal to 11 is also 2 over 36. That's why the given histogram or the graphical presentation of the discrete probability distribution is symmetrical as to characteristics. Okay? Now, I hope you're able to learn about discrete probability distribution from the exploration that we have to the examples that I provided. And with this, always remember that discrete probability distribution is a table or a formula listing possible values that a discrete random variable can take on along with the associated probability. And it's always your decision whether you are going to use the tabular form or the equation form. Okay? And for the properties, the probability of the values of the given discrete probability distribution will be from 0 to positive 1, while the sum of the probability distribution is equal to positive 1. I hope you learn about my discussion today and see you more on my video presentation about random variable. With this, God bless everyone and happy learning.